All right, good morning. Welcome back to Elements of Calculus 2. We are going through our series of the practice test, and this is problem number 12. Okay, so this is just to find a limit, and usually we have to find a limit. We just go ahead and plug in and see what happens. So if I plug in 0, we get natural log of 1 plus 0 minus 0 divided by 0 squared. Natural log of 1 is 0, so we end up with 0 over 0. Oh my goodness, that's an indeterminate form. That means we can use L'Hopital's rule. Okay, let's go ahead and do that. So L'Hopital's rule means we have to take the derivative of the top and then of the bottom. So taking the derivative of the top here, we end up with a 1 over 1 plus x times its chain, it's just 1, minus 1 all over 2x. Okay, so that's what we have first. Okay, now let's try it again. Limit as x goes to 0. Plug in 0, we get 1 over 1 plus 0 minus 1 divided by 2 times 0. We have 1 minus 1 over 2 times 0, which is, oh my goodness, we have another indeterminate form. Who would have guessed? So again, we have to use L'Hopital's rule again. Okay. By the way, just realize like when you guys are doing your problems for your exams, it will almost always be a L'Hopital's rule problem where you have to do it more than once. Okay, it's just the way these things work out, and that's the way that's how those problems tend to go. So expect it. Like, I mean, if it only has to happen once, that's great. Because I can't always find a good one for you guys to do that twice. But be aware that it is often going to be twice. Okay, let's go back and look at what's going on. We have 1 over 1 plus x minus, I'm going to do it this way, 1 plus x over 1 plus x. That's a fancy way to write 1. Okay, divided by 2x. I just wanted to get the fractions together on the top because I didn't deal with a lot of extra stuff here. Okay, so what do we have here? We have 1 minus 1 minus x all over 1 plus x all over 2x. Okay, we have top, we have a bottom. Let's clean this up a little bit. We're just going to get a negative x over a 1 plus x over a 2x. Okay, there's other ways to do this. Okay. And again, we're trying to apply L'Hopital's rule on this thing because we did try to go to 0, but we end up with a 0 over 0. So let's go with L'Hopital's. Now, when we take the derivative of the top, we have a little bit of a problem because this is a quotient, which means when we take the derivative of just the top, we have to apply the derivative, the quotient rule, to just the top. Okay, remember that? So the derivative of the first, negative 1, times the second, minus the first, actually minus the first, so it's minus a plus, times the derivative of the bottom, that's going to be 1. Derivative of 1 plus x is just 1, divided by 1 plus x squared. Now on the bottom, the derivative of this bottom is just 2. Okay, so we had the derivative of the top, which itself was a quotient, divided by the derivative of the bottom, which is just going to be 2. You still have the limit as x is going to 0. So let's go ahead and plug in 0 for all of this stuff. So we have negative 1 times 1 plus 0 plus 0 divided by 2. And we end up with a negative 1/2 as a limit. Okay. I'm going to pause you guys for just a moment so I can show you a graph of what this looks like so we can kind of see it. So I'm going to pause. Okay, so just pause to bring up Desmos here for us. Um, all, all, all we do is just type in the problem. Desmos is a great tool. If you're not using it already, public homework, please start using it. It's fantastic. It's free. But I wouldn't expect you to be able to graph this thing by yourselves. Like this is a lot to ask to be able to graph this thing. I wouldn't be able to graph this thing by itself. But as I kind of scroll in here to see what's going on with my value here, we can see as we get closer and closer and closer to 0 here, we get really close to negative 1/2, just so that you have an idea of what's actually going on. Okay. You don't want to use a table of values or anything like that. You want to use you want to do this algebraically. It's kind of a thing. But since that's a little bit of an unexpected result here, I just wanted to show you a picture of like what's going on with this thing, so you can see exactly what's happening. Here's the kind of what's happening. So anyway, thank you very much for tuning into the video and watching. Again, L'Hopital's, you have two jobs to do. You have to make sure that you are checking to see if it's in indeterminate form first. Once it is in indeterminate form, we apply L'Hopital's to go ahead and finish the rest of this thing. And then chances are with any L'Hopital's problem, it's going to be a problem where you're going to have to go around this circle. You're going to have to go around this rhyme more than one time. Okay, so just be aware that that's the kind of problem I tend to ask. Okay, thank you very much for watching the video and good luck on the test.